Hey there, kids. Today we're going to talk about writing constructors for subclasses. To start, you're actually going to have to download the zip folder that we have with a couple of the Java files. If you take a look at them, there's only a few that are in here: the entree, menu item, menu tester, and drink. And this is set up in a little system of a hierarchy where our menu item is a pretty generic item. You notice it has a name. There's a constructor that is a basic non-parameter constructor and a constructor that takes a name. The difference is whether or not it prints out the name of the item, as you can see, or if it prints out something without a name. There are two subclasses of this called entree and drink, and you'll notice that both of these are going to extend the menu item. There are a couple of small pieces of this where you will have to call your superclass. We will also assign the number of sides that we have for our particular entree. We'll get some print messages. And the drink class, again, something similar but a little bit more complicated, where the number of ounces, whether the drink is frozen. We have a couple different variables we assign, and then again, just different printout statements depending on the certain status of the Boolean. And we'll kind of play around with this as we walk through our examples a little bit to give you a rundown of this as to what we can access, what happens if there are certain pieces of information missing, and things like that. So as a recap, this was kind of the superclass subclass relationship we talked about earlier between the person, generic, the student, and the worker, who are more specific versions. And we had like the two different versions of the classes here. So I'm not going to spend a ton of time. Just remember that you do need that keyword extends in order to really inherit everything. So the big thing about this is that subclasses don't actually inherit the constructors from the superclass, but we still need to use the superclass constructors in order to actually initialize all the variables that we have. This typically means that every subclass will need to write its own constructor, and inside of that constructor, we will need to make a call to the superclass constructor as well. Huge things that we need to kind of reference that down here. When you create an object, we must make sure that we have a call to the superclass first for the constructor. If that line of code is not the first line of code in the constructor, you'll see that we'll actually run into an error. We could see this if we pop back to our actual coding scenario here. Let's go to like the entree, for example. We know from the menu item that I am allowed to give a constructor a single variable, which is a string. And you'll notice that as I have the string name here, I do feed that to my superclass constructor, which initializes the name. If by chance I wanted to take this line of code and just swap it out where I switch these two lines, you'll notice that we do receive some sort of an error. And when we hover over this error, it does mention that the call to super must be the first statement in the constructor body. So even if you try to attempt this on your IntelliJ, it won't let you. This is something, though, that will and can go wrong on a free response question if you accidentally forget to put this as the very first thing that we look at. So on this, your subclass always has to call its parent constructor. So I always think of this as like setting up your prerequisites for this. You use that keyword super in order to access it. And the big thing is that if the superclass constructor has parameters, then you must call that particular one and then feed it those parameters. And we'll run into a couple scenarios here where we see this work out in different manners. So in this case, when we had the student class who extended the person, every person had a name and a birthday. So you'll notice that you do accept those as parameters even when you're building a student object, but those two variables are actually fed into the superclass constructor right away, first line also. And then after that, we're given our instance variables that are specific to a student immediately after that. So again, superclass call first, and then get your variables done after that. The way that we kind of look at this, and this is a very great visual of this, when I call the superclass constructor, the name variable is actually being taken over by the string that you see here. Same with the birthday variable, so it's kind of like calling another method, or in this case, another constructor, just matching up those parameter types. When a subclass constructor doesn't explicitly call a superclass constructor, Java actually will imply that this is going to happen. And what I mean by that is, if we had a situation like, hey, I'm not going to write this super call in here. When I build an entree, I'm just going to try and do something along the lines of this. Well, what we don't actually see here is that technically there is this line of code written here that is naturally implied if indeed you forget to write that in there. The problem that might occur in this situation, though, is one that's kind of a strange one. If we come back to the menu item, you'll notice that I do have written out here a constructor that takes 0 parameters and does a few different things for us. And in my entree class, Remember, this is, again, kind of considered, even if I don't write this line of code, it's considered to be the first line of code that's actually written there. Well, what strangely happens is if I don't have a written out constructor with no parameters, this will actually cause an error, which is something we don't typically are used to seeing. What I mean by that is if I pretend like this code is not here and I comment out our constructor that we have here, you'll notice that when I come over to the entree, it comes over and says, hey, we have an issue right now. And it comes through and says, I'm sorry, but I can't find a constructor that doesn't have any or no parameters whatsoever. So this is strange, but we actually do need to make sure that in every single class that we're going to start extending, we have to write out that default constructor, even though typically it might just give default values. We do have to physically have it appear inside of our code. And that's kind of what these last few lines are talking about. If the constructor doesn't exist, the program will not compile without that call being made, and we specifically also need that code physically present in that superclass. And so here's a couple examples that we see here when we have our shape class and then a more specific version of a shape. You will notice in this example they're talking about how my subclass has to pass in parameters to superclass constructor. In this case, if I have a shape constructor, I need to feed it the number of sides, but that variable number of sides doesn't necessarily need to be a parameter of your rectangle constructor. For example, if I decide to build a rectangle, it is guaranteed that that rectangle is going to have 4 sides. So sometimes we can feed direct values to those constructors. But again, the thing that we have to make sure of is, does this data type that we have right here match the data type that that parameter does, or that constructor does need? So again, it's a matter of, do I accept this as a variable? Is it something that I need to do? Or can I just assume, hey, in this case, every single rectangle, or even something like every single square, would naturally have 4 sides? So that's not something I necessarily need to ask for. With this one, they kind of talked about, yes, this example of when you feed it the value 4, you're really feeding that value into the number of sides that we see there. So in this example that we have here, this is the one where we have like the no argument kind of constructor. When we have a person and a more specific version of a student, you will notice that your student didn't make a call to the superclass constructor. But again, right here, we can assume that that is actually implied that it's there. Although you'll notice that it does not have parameters, the call is to the default constructor. So it would not be running this constructor here, but rather it would be running this one in which the name and the birthday are actually not set. And so we come over to this other side, we say, well, what happens if I decide to build a student object? I call the student constructor that takes no parameters. Okay, that means I'm calling this constructor right here. First line of code says I'm going to set these as not set, and then I'm going to go ahead and assign the grade and GPA. Now remember, you technically have, in this student class, you have access to any public information that is given to you from the superclass. These are directly accessible, which means I can go ahead and call any of the methods that I see here that I'd like to use. Or if there's getters and setters methods there, I can always use those as well. For example, my students, this getName method would very likely exist inside the person class where the name variable does exist itself. I don't physically see it in the student class, but that is something that is inherited and I do have access to directly as well. The method, not necessarily directly to the variable, since the variable is private. The same thing over here, this is slightly different. The student that we have, the getGrade function does exist in that student class. We can assume that this is something that we would have right here in this class for the getters and setters. So we have access to all of our classes, methods that are in the class itself, as well as all the methods that are inherited from the superclass that we have above it. So this would make sense that when I try to get the name, it did call that default constructor where we said, hey, you didn't set your name. But when I get the grade, that was something that we did assign to be the value of 9 with our default constructor, and we should see that print out there as well. So again, you can have several tiers of these superclasses. Just to give you a general idea, this is the person class. They said a more specific version of a person could be a student. A more specific version of a student could be a high school student. And the crazy thing about this is kind of how these constructors work. When you decide to build a high school student, you actually need to sometimes ask for all the information for the things that are way up at the top, even for a person. Every person has a name and a birthday. Okay, well, what else do I need from this? Well, if I'm extending the student class, I also need to make sure that I have some sort of a grade in this instance. And you'll notice that I do have that right here. And then the one thing that's specific for this high school student is that high school students will have a GPA. You'll notice that variable is existing right here. So I've actually accepted all the variables that I have. Well, this particular high school student needs to call the constructor of its superclass, which is the student class. The student class says you have to provide me with a name, a birthday, and a grade. Well, you'll notice that I accepted those as parameters, the name, the birthday, and the grade. The only difference is I have to call those with the superclass constructor there. So this is something that my student class has to deal with. I use the keyword super, feed it the appropriate data, and then after that I can assign my GPA to be the value that I was given as well. Same exact thing happens when you kind of look at the student class. If you accept some sort of a name, a birthday, and a grade, the person class needs to have their name and their birthday. So this is something where the student is calling the superclass constructor, aka the person constructor, feeding it its appropriate data. And then last but not least, we're going to talk about what I call the top dog of the food chain. Technically, every single class that we have written so far has extended another class. We just haven't written it necessarily because it is implied. There's this class called the object class, and the object class has the ability for an object, to print itself out. So it has a toString method that is pre-built in. This is why when we print out objects, technically it gives us that hashtag and a bunch of crazy letters that come on after it. But it's kind of crazy to think about that everything is an object, so we're still following that is a relationship. A dog is an object. A building is an object. A student is an object. And so this object constructor doesn't take any parameters. It's really just a kind of a basic class that just passes down a toString method for you guys to use. So again, whether we call this explicitly, which means we would literally have the word super with a set of parentheses inside of it, we've never written that in any of our classes so far. That's because it's implied. When we write our constructor, even though I don't make a call to my superclass constructor, aka the object constructor, it is automatically going to make a default call to that class for me. So although I don't necessarily see it, every single one of these classes does have a super call inside of its constructor. So even though I've made the person, the student, the high school, like I said, object class is going to be a top dog of just about, it literally is top dog of everything that you guys are going to look at. So to recap kind of what we've been talking about, since constructors are not inherited, our subclasses definitely need to write their own constructors. The first thing that has to happen inside that subclass constructor is we do have to make a call to the superclass constructor and feed it any appropriate parameters. If by chance you do not make a super call constructor, a call to the superclasses constructor, Java will kind of make a no argument call to the constructor for you. That does need to be defined in that class, meaning you need to implement that method or that constructor, otherwise you will run into that error. And then, of course, when no superclass is defined, meaning like every class we've written before this, we've never wrote extends before, the object class is automatically your superclass. There's automatically a call made to that constructor. And again, the only thing that's kind of passed down to us, or the things that we inherit from that object class, is the toString method. Every object has the ability to print itself out. Probably not in the format that you would like, but it does have the ability to print itself out. For homework, ladies and gentlemen, you guys will go through on AP Classroom and complete 9.2 for me. That's all I got for you guys today. I very much appreciate you guys listening, and I will see y'all tomorrow in class.